But let's start this afternoon with Muhammet's presentation.
All right, so let me, this is a joint work with Alp Şimşek, and the title is Durability, Deadline, and Election Effects in Bargaining. So as you can see, this will be a bargaining paper. And there are several effects here that we are talking about. So deadline effect is something very common in bargaining where people wait until deadline to settle. Election effect is also very common in politics where we don't pass laws before the elections and then you pass after the elections. And in this paper we show that these are quite closely related and they are all different instances of something we call durability effect. Basically that shows that when the bargaining power becomes durable, this entices the players to wait until that moment. Okay, so let me start with my motivation. So the first one is about deadline effect. So in bargaining, negotiators wait until near deadline to settle. This is called deadline effect. And examples in experiments, they wait until the last second. Like these are like 1 minute experiment. They come last second and they try to bid in the last second. In labor negotiations, they negotiate in the last hour. So there's, like tomorrow there will be a strike. They don't negotiate all those weeks, but then the night before that they are like stopping the clock and negotiating to cut a deal. In pre-trial negotiations, in the United States, only 5% of the cases go to actually court. 95% are settled. And in those 95% settlement, actually, they don't agree ahead of time. They agree on the step of court house. And so, we knew these things as, people who know bargaining, we knew these facts. But then in last 2 years, Americans also, like ordinary Americans, learned these facts very well. The reason is there were a lot of high-level negotiations between Republicans and Democrats, and they all were led to crisis. One of the crises was called debt ceiling crisis. In this one, Treasury declared that they were going to go on default if they don't get money by August 3rd of 2011. So government had to raise the limit for debt ceiling so that they could borrow. Otherwise, they would go on bankrupt. It would be the first time in United States history that they will go bankrupt. But somehow, Tea Party Republicans didn't want to do that. So there was these negotiations. As you can see, finally they reached an agreement on July 31st, and they passed the law on August 2, so that they wouldn't go bankrupt on August 3. Of course, still the U.S. credit rating went down just because of this thing. All right. And then there was next year in 2012, there was this fiscal cliff crisis. Basically, Bush tax cuts were gonna disappear on the New Year Eve, and there were these negotiations. They kept negotiating until the New Year Eve, that night. And then they finally settled on New Year Eve. And next day, basically the New Year, and then actually Obama signed the law on January 2nd. This is before the market started, because they were afraid that if they didn't pass the law, markets would collapse by this thing. So this goes on. One thing is, as you can see in these things, deadlines are also very stochastic things here. It's not that, there's something. So here in experiments, yes, there is some 5 seconds, but you don't know whether how much your time your action is going to take. But when you look at here, for example, that ceiling, it's like when they run out of the money. This is just a number, August 3, but it might go to August 4, maybe even, September 4. We don't know when the money ends. So that's the deadline. It's a very stochastic thing. We don't know when it's going to end. So these things are like that. For example, in pretrial negotiations, this is when judge or the jury reaches a decision. You don't know when they are going to reach a decision. You are just waiting. Okay, so it's a stochastic thing. Good. So my second slide is going to be about something that seems to be somewhat different. This is politics. In politics, basically newly elected presidents pass many laws in their agenda. The first 100 days is very important, they will say, okay? So if you pass them, you pass them. If you didn't, probably you won't. But also there is another thing that there is often political gridlock before the elections. So if there is going to be election in November, in August, in April, people are not going to pass laws. You are not going to be able to do anything. Okay? So we will call this election effect. The example, for example, one example is the following. In 1999, this was Clinton era, there was huge surplus, and they were expecting a lot of surplus too, and Republicans offered some tax cuts. Clinton rejected because he wanted to negotiate a better tax cut, different tax cut. But the Republicans didn't negotiate after that because they were hoping that in 2000 they will elect a president, the Republican president, and they will pass a better tax cut, and that's what happened. George W. Bush was elected, and then he really passed one of the probably the most major tax cuts in the history, and it was, you know, tilted towards Republicans. So obviously this is an anecdote, but actually we have also data for this. Where is the data? Oh, here we go. So this is basically, politicians actually studies this a lot. This is from a Mayhew who wrote a book about this thing, and this data my co-author picked from them, that book, and we looked at it. So this shows the following. For, you know, in the United States, we have congressional elections every 2 years, and presidential elections every 4 years. So for any president, you can think about the first 2 years, one Congress, second 2 years, another Congress, third and fourth. Goes like that. Here there is another election. No, this is like first 2 years here and second 2 years here, and there will be a presidential election here. As you can see, and then these guys measured the important laws passed in each Congress, and then when you look at the first 2 years, there were 13.6 or 13.7 number on average. But second 2 years, only 10.2, 10.3 law passed. This is like significant in 90%, but insignificant in 5%, but 95%. But you know, if you think about it, we have very few data here. Okay, so still, but you can see that this is 25% less than this. So there's a big jump between those two. And so, in fact, I'm going to show you another picture. When we looked at this picture, and our theory also suggests the following. This is putting a lot of data in together, but let's separate, because in the United States there are term limits. It goes all the way, you know, you can be re-elected, but you cannot be re-elected after that. So we put this first year or 2 years of a president, second 2 years of a president, third 2 years of a president, and fourth 2 years of a president. When you see what's happening. So the largest one actually is in the first year of a newly elected president, and it goes down in the midterm, after the midterm election, and he gains some political capital again, and then he goes down all the way to 9. When you look at 14 versus 9, it's huge. So these guys are lame duck. Okay? So this is a data that we found. So basically this shows that somehow this is a data that shows that before the elections, people don't pass laws. There's a political gridlock, and after the election, you overcome that. Even here, you see that, you know, like just right after the election, it changes. Okay, so this is the second one. That was election effect. The third one is about durability of bargaining power. What we are going to do, we are going to connect these two seemingly distinct things through something we will call durability. Okay, much simpler. Okay, so in real life, bargaining power of individuals or parties are actually durable in the sense that it's continuous. It doesn't jump from one moment to other. So, but it's a stochastic. It changes as time passes. It changes randomly, but it changes like in a very continuous way. And also, its durability sometimes changes in expected ways. For example, before the election, the bargaining power is not so durable. After the election, it's very durable because this guy is gonna be in that seat for the next 4 years. You have to, do that. So in theory, however, this is in reality. In theory, bargaining power is often modeled as probability of making an offer or making an offer. Because why? When you make an offer, the other guy can only say yes or no. You are making a take it or leave it offer. So for that moment, that party has all the bargaining power. And then sometimes you might say, okay, I'm going to use probability to make it a bit softer. So, and of course, this is the way I think about bargaining, but people usually use that probability of making an offer. They think that it's a protocol, but the protocols they take usually assume that this bargaining power is highly transient, okay, non-durable. How? Think about Rubinstein's alternating offer bargaining. How do you offer? I offer today, tomorrow you offer, the day after I offer, and so on. It goes back and forth. What does it mean when, especially, we would like to take this discount factor going to 1, continuous time limit? What's happening? In one instant, one party has all the bargaining power. In the next instance, the other guy has all the bargaining power. This makes it very non-transient. Or you could think about another one, random proposer model. If you take that, making an offer as the bargaining power, random proposer also says that with independence, it says that tomorrow's bargaining power is unrelated to today's bargaining power. Again, it makes it non-transient. Or you can think about, the probability of making an offer. In that case, bargaining power is constant, it's not changing, or something like that. All right. So what we do, okay. And then this last ingredient of our model, optimism. Well, basically, in bargaining literature, in experimental stuff, etc., they report that excessive optimism is common in bargaining. So you ask what's the probability that judge is gonna go with you, and you say 2/3, and the other guy also says 2/3. They add up to more than one, right? So there's some optimism, and people think that this is a main source of delay and disagreement in bargaining. Let me give you an example here. That example I gave you, Clinton versus Republicans in 1999. Here, example says that Republicans didn't negotiate on tax cuts in 1999 with Clinton in the hopes that they would get a better tax cut from possibly a Republican president like George W. Bush. This is like we took that sentence from some political scientists. When you think about it, this doesn't make sense. Why doesn't it make sense? Because this is Clinton's last chance in his legacy to pass another major law and write his name there. So if they agreed about the probability of Republican versus Democrat president being elected, so there will be an expectation, some continuation value. And Clinton would like to actually agree something more Republican than that so that he would put his name on it. And then, yes, we would see, like Clinton would, this makes, Clinton lame duck, but being lame duck also allows him to be, like a lame duck president also pass a law, but except that it would be against his interests. It won't be as good as he would have if he had political capital. But in this case, they didn't do that. They actually waited. They waited means that actually perhaps Republicans had higher expectations about having a Republican president, and in comparison to Clinton's view, Clinton thought that Gore could pull that thing. All right. So this is the optimism. So what we do in this paper, we develop a model of bargaining with possibly durable bargaining power, and also we allow optimism and stochastic deadlines. In fact, all these three are important for the theory at the end. We show that the deadline and election effects are two sides of the same coin. Basically, they are instances of durability effect. It says that durability effect says that if the durability is expected to increase at some t star, then there is a period of disagreement before t star. All right. So basically, in the deadline, durability increases because of the deadline. When there is a stochastic deadline approaching, that means that we are stretching the time. Right? Because think about, like, if there is a 10% of the game ending, you know, think about, like, 99% of the probability actually the game is going to end 1 minute later. For you, that 1 minute is an age. It's like, you know, it's years and years of discounting. That way, what happens, that deadlines make the stretches the time and makes the bargaining power more durable. And basically, this is an instance of that durability effect. So before the deadline, that's why we have this long period. Elections, on the other hand, what the election does, just before the election, durability drops, dips, and then, so at that moment, there's a long jump in the election we are foreseeing, but that thing also leads to long delay, much before that thing dip happens. Okay, so that's basically the key. We'll see, I'm going to show you examples, and then what we do, we relate the size of the deadline election effects to level of optimism, durability of bargaining power, and hazard rate of deadline, etc. All right. How much? What?
22 minutes.
Oh, okay, good, I have a lot of time. Just one, yeah, okay, so 3:10, okay, good. 3:30, I guess that. Good. So let me give you some brief literature review. So there's an applied, sizable applied and empirical literature on optimism in bargaining. I'm not gonna, say that, but I have a survey article on that if you wanna read. And then before, in my dissertation, I developed this dynamic models of bargaining with optimism, durability. So these are those things. Here, basically, in fact, it shows that optimism doesn't necessarily lead to delay, and then here it says that learning, when combined with learning, it leads to delay because of persuasion effect. And this one, here I try to study deadline effects with optimism, with basically what I was showing with if the deadline is not stochastic, then you would have a deadline effect, but if there was a little bit noise, it would disappear. And I thought that mathematically it was interesting, but obviously people thought, well, most deadlines are stochastic, so what are you talking about? I never published that, and then with ALP, we took that little note, and then actually we wrote much different paper. All right, so these are the thing. So on deadline effect, there's an experimental and empirical literature on that. For example, this paper, 1988 paper with Alrota and his co-authors in AR, basically these guys were running bargaining experiments for years and years. They were trying to test different bargaining theories, but at the end they realized that there's only one thing that was common in all of their bargaining: deadline effect. They just discovered that there's deadline effect. Okay, so then they wrote this paper, and this paper probably is better known than all the other papers they wrote in the meantime, that they wanted to write. And then Roth and Oakenfels have another paper about why deadline effect in eBay auctions and so on. And there are also there's the other empirical literature on deadline effect in law and economics. In theoretical literature, Catherine Spire was an MIT graduate student at the time and wrote in her dissertation, she showed that deadline effect. She had an example that illustrated that deadline effect can come out of bargaining with incomplete information. They just made up a game to make it look like deadline effect. There is a new paper Jack Fanning from NYU, he just started in Brown. He has a beautiful paper that shows that actually if you take Ebru-Gül model, deadline effect just comes as a linear equation from that model. It's beautiful. So, and that's a very good paper. And then, so these are the theoretical ones. Election effect, there's a, Mayhew is the guy, he's at Yale on this thing, I found him, and then so we got data from him, we wrote, and then the binder wrote another book, and there are books on these things. Theoretically, Ortner has another paper, he's at BU from Princeton. He also has a theory similar to ours, but different, but he talks about election effects. He shows that his theory is based on passing laws today affects the probability of winning or losing. That's why you get this gridlock. But you can test, obviously, those things. And then our model will be continuous time bargaining, so there is Ortner is continuous time, Ambrose and Liu has another continuous time bargaining paper. All right, so this is the literature. So let me talk about the model. Good. So we consider two risk-neutral players. They are trying to divide $1, and X is the share of player 1, 1 minus X is the share of the player 2. That will be their utility. And time is continuous, so that's not like typical bargaining model that we are doing now. So the time is continuous. Payoffs from striking a deal at time t is e to the minus rt times x, and for player 1, e to the minus rt times 1 minus x for player 2. So r is your discount factor. Although the time is continuous, they can strike a deal only on like certain discrete times, like 0 at 1 over n, 2 over n, 3 over n. We are going to let n go to infinity. All right. So far it's like bargaining, but what's going to happen? Oh, this is also different from typical bargaining. So now I'm going to define deadline. Deadline, we are going to deadline as a stochastic thing. So it's a r plus valued random variable d with CDF capital F and PDF little f. So randomly it arrives. When it arrives, basically after d arrives, then each gets 0 and the bargaining ends. So if you agreed before, then you agreed. Okay, so it's a random variable. All right, so this is key. Let's look at the effect of having a stochastic deadline. When you look at the effective discount rate of at time t, it's like this r plus the hazard rate of deadline. All right, so that's what I mean by why deadlines are equivalent to making this bargaining power more durable, because deadlines are precisely equivalent to making the time pass longer. And if you had a continuous function, if you stretched it, it would look durable, right? That's the key. So I wish I did that here. Okay. So in effective, and you can see that delta TS, the discount factor between T and S, is like this, and then you take derivative and you get that. Okay. Good. So far this is somewhat more new than usual, but our main newer new things are going to come next. So this is where we are going to define things somewhat different than literature. So we define bargaining power of a player I as an exogenous continuous time stochastic process, pi ti. And this is exogenously given to us, and it's independent of how frequently these people are making offers. All right? Good. And also, we are gonna, this, like Rubinstein's bargain would be like so fast that this doesn't have any limit, right? In the limit, here we are gonna make it like almost surely continuous time paths, piecewise continuous time paths. All right. So and then there will be some space omega, and they will, those numbers are adding up to 1. And the key assumption here is that at time t, each person's bargaining power is common knowledge. We know what the bargaining powers were in the past, but we don't know what the bargaining powers will be in the future. Okay? The game is as follows. We are going to make this bargaining power as follows. Player I is recognized as the proposer with probability pi ti. The recognized player offers some x, and if the other player accepts the offer, then the game ends when picking x. Otherwise, the game continues to the next period, unless there is a deadline arrival, in which case the game ends and player gets 0. Okay? So basically, original one we were like making more philosophical point without games, etc. But we were saying that this is equivalent then, and eventually we thought, okay, this actually we are analyzing yet another, when you think about it, yet another random proposal model, but it's more general. And also, when we take the like continuous time limit, we are not playing with that process. In the other one, you would play with that. Okay, that's the key. What? Yes, yeah, obviously, yeah. So we could have just put all the way in the F. But yeah. So, but sometimes we want to put, okay, let's get some deadline. Yeah, you are right. Okay. But we are going to make some comparative statics and so on. We studied subgame perfect equilibrium of this game. Okay, good. Yeah, also, Yuliy responded to this. Also, this sounds familiar to him too, right? And we have possibly non-common priors. This will be where we will add optimism. Priors on P1 and P2 on omega, which is about the bargaining powers. So players have common view about the deadline, how the deadline is coming, but they have subjective view about how bargaining power is going to evolve. We are going to write ETI is expectation operator of I at t. We define optimism at time t about sometimes s as follows. We write YTS equal to, this is the amount of optimism. Let's write the second, let's look at the second line. Second line is makes much more sense. Take a player I, ask him what's your expected value of your bargaining power at time s. He tells you this. You turn to the other guy J, his opponent. He says, what is the probability, your expectation of your opponent's expected present value, bargaining power at time s? Opponent also makes another expectation. If they had common prior, this would be 0. We look at my own expectation of my bargaining power minus my opponent's expectation of my bargaining power. This is clearly the level of optimism. Okay? And then you can write this symmetric like this, showing that this doesn't matter which player you are doing, you will get always the same result. So that's why it's called optimism, rather than putting things. All right, so you add them up, each person's own expectation, and subtract minus. This measures the level of optimism. Good? So let me tell you, if in a standard model, this would be always 0, because you would be assuming common prior. But we don't have common prior, that's why it could be positive or negative. And let me first, there are some basic results that says that you could actually solve this using, there's a unique solution, and the unique solution is continuation value is given according to this equation. But the key here is the following. You take a person, you ask player 1 his expected value share waiting 1 more period, player 2's own expectation of player 1 more period, that gives you a number, that's WTA1N. If this number is greater than 1, then you cannot make these people agree, because each of them, their sum of what they want is more than 1, and you have only 1. And if it's less than 1, then you can agree. So agreement only if this is less than or equal to 1. Okay, that's how this agreement happens in this model. Okay, and then if you had common prior, if you had a standard model, actually we have a very nice solution, very simple solution, basically present value of future bargaining, rents that you will extract, etc. All right, so what I'm going to do next, okay, good. I'm going to present some Poisson model, some more simpler model that's much easier to analyze, And I'll illustrate everything on that model, although we have more general results in the paper. Okay? In this one, so we assume that there is some Poisson process with arrival rate lambda, and at each arrival, a new pair of bargaining power is selected, and this bargaining power remains constant until the next arrival. So basically, bargaining power constant until some extraordinary event happens. When that happens, we reshuffle the deck. Okay? And this is from a fixed distribution, and like that. Okay. Let's write pi bar I for the expected value of player, pi I according to player I after when there's a reshuffling. Okay. We are going to write y bar, this plus this minus this, for the long run optimism. This is how much they are optimistic if conditional on things being reshuffled. Okay. So how would you talk about durability of bargaining power here? Durability here is how often that arrival happens. It gives you variability. 1 over that rate gives you durability. So 1 over lambda is the durability of bargaining power. Measures durability of bargaining power. But what we want to do, we want to actually talk about, it turns out that this is the key, this becomes the key. Effective durability rate, which is effective discount rate divided by lambda. Okay, this includes the effects of deadlines, etc. too. So that will be key. Okay. Okay. And expected bargaining power is something like this. As time go forward, there's more. It's less like that you have the current bargaining power, but when there's a new bargaining power, your expectation is this. And then what's optimism? Optimism becomes, you add those things up and subtract 1, you get this. 1 minus exponential times y bar. So what does it mean? At the current moment, if you ask our opinion about what happens tomorrow, we have very much similar views and level of optimism is nearly 0. But as time passes, it gets larger and larger, and in the limit, it converges to y bar. It's a very nicely increasing bargaining power, which actually makes a lot of sense, right? Good. And then we basically first show this thing, and then you can solve it. We have a unique solution, we found the unique solution, and unique solution, assuming that this rho is constant. Your share in agreement is a convex combination of your current bargaining power and your long-term bargaining power. Okay? But the key here is the ratio, the way, if you divide this K with L, you get rho. When rho is high, you put a lot of weight on your current bargaining power. When rho is low, you put very little weight on your bargaining power. But also, there is y bar here at the bottom. The reason is, although we both agree what this number is, we have very different numbers for this. We have disagreement, so to add up to 1, actually you put this. So in general, optimism of your opponent always hurts you. That's why you get that number, like that. All right, so this is the model. What I'm going to do, I'm going to play, some simple examples. I'm going to show you why this model will lead you, the deadline and effect and all those effects. Okay, so this is the picture for deadline and durability effect. Let's fix T star. After T star, that effective durability rate is rho 1, which is R1 hat divided by lambda 1. This is one parameter specification. But before T star, this rho is a smaller number, R hat 0, lambda 0, like that. So these are constants, okay? These are all constants I just picked. We picked so that this is larger than this. So basically, effective durability rate remains constant, slow at until T star. At T star, it jumps up and remains constant after that. All right? So how can you solve? I already solved from here on, and I'm going to show you that there will be delay here. That's the next slide. Basically, assume that rho 1 is greater than rho 0 significantly enough so that when you multiply this congruence parameter, this is the weight of the current bargaining power, multiplied by y bar, that will be greater than rho 0. Okay? This is important because this measures the share of amount of optimism about long-run optimism at T star about your own share, because that K affects that way. All right, so what we show, suppose that it's like that, it jumps up, then players disagree on an interval T star minus delta bar divided by R0 T star, and agree at time T star. And at T star and thereafter. So basically what happens here, there's some period here, they wait, they agree, they would have agreed here, but if they come here, then they are gonna disagree, and agree here, like in deadline effect, okay? If that W, if the game starts here, it will be, you are waiting until start and you are agreeing that. And then the length of that period is given like this. Basically, it's, as you can see, the reason I wrote this way, this is the, this is discount, the amount due to discounting, and this is the amount of optimism, basically. All right. So I'm not gonna. 3 minutes? Okay, good. So let me tell you what the durability, why this is durability effect. If I took R constant, if I just increase the 1 over lambda at that T star, I would get durability effect, durability increased. On the other hand, if I kept lambda constant, but some deadline started arriving, then what would happen then with some exponential rate alpha, then then rho 1 would become something like this, R plus alpha divided by lambda 1, so it would increase. So deadline effect and durability effect are the same thing. All right? So then we do all these things we relate them to, how that size depends on the other things. But given that we don't have time, let me go to election effect. Election effect is like this. I can model election as, so there's an election at T star, bargaining power is constant at rho 0, high all around, but there's a small time where bargaining power dips. Okay? No, bargaining, durability. Durability is constant all around, and here durability dips because there's an election. All right, and so we write it this way, this lambda. Okay, so it goes like that. Lambda obviously jumps up at in that period, and lambda 0 otherwise. And then we take epsilon 0, but there will be this term e to the minus lambda prime, lambda I, that will be called incumbency effect because it's the probability that you will survive the election. And then we show that, in fact, that's what happens. This epsilon is very small. But since there is dip here, so from here to here, there is a big jump. Because of that jump, then all of a sudden there's a long period here where disagreement. Okay, so there is disagreement from here to here. And then we measure that size. That's what it happens. And then one thing that I would like to emphasize is obviously this thing always is increasing with optimism level. Another thing that's basically, this effect is decreasing in the incumbency effect. So if there's a lot of incumbents, you cannot have a lot of optimism because that's disciplines. Okay? So that's what it is, etc. There are all these things. And this brings me to this picture. The picture, look at what happened here. Here there is term limit, there is no incumbency, and there is a huge election effect. Here there is incumbent is rerunning, so there is an incumbency effect, but that effect is not that large, as you can see. You should measure this versus this versus that, okay? So you will see that one, it goes 9 to 14, the other one goes 11 to 13. This will be this will be the opposite if you had somehow you thought I'm gonna affect the elections. Okay, how many minutes do I have? 0. Okay, good. So deadline effect is prevalent in bargaining. Election effect is common in politics. And we develop a model of bargaining with possibly durable bargaining power. We show that deadline and election effects are two sides of the same coin. They are all instances of a durability effect. If the durability expected to increase, then there will be a long period of delay, and these things relate to other things. All right, thank you.
Thank you, Muhamet. Now, Philippe Yachin is going to discuss the paper.
Thank you. I thank Umberto and Vinicius for the invitation. So I started with a caveat. I'm not a bargaining theorist. And so I actually I tried to bargain my way out of that, and I failed. So what I'll do is I'll try to present an outsider's perspective on the paper. I'll try to show a little bit, kind of the earlier setup of the paper is fairly simple. So I won't try to simplify much. I'll try to offer a new perspective on how they show the results. And then towards the end, I'll conclude with a few questions that I wanted to ask. Okay, so the main motivation of the paper is that you see a lot of last-minute agreements when you look at empirical bargaining. So, and one of the reasons that people in the literature have pointed out for that is that people have self-serving biases. So people would tend to think that they are going to be able to, in the future, reach better bargaining positions than they have in the present. And how can this self-serving bias generate a delay is that potentially, if I receive an offer today, I might think that in the future I have a better bargaining position, so I might not be willing to take that offer today. And the sender might also not be willing to offer me something, a reduced offer, because reduced from his side, because the sender also thinks that she's going to be able to find a better bargaining situation in the future. So you can see how this could generate potential delays, and the literature started with some very simple examples of that. And Muhamet has a very interesting paper from 2003 in which he shows that under very mild conditions, this kind of argument breaks down. So what he shows in that paper is that discounting undoes much of what disagreement can do. And the point about discounting is that we cannot disagree for too long. Because with a fixed discounting, if we disagree for too long, what's going to happen is that our payoffs are going to get arbitrarily small. So we should, if we expect to disagree for too long, we should agree now. So that kind of, so that's a main feature, and one of the things I'm going to try to emphasize is that discounting undoes disagreement in these settings. Okay, so the paper has two very simple, very nice examples. So the two examples are, one is about the deadline effect. And the idea of the deadline effect is, imagine that I think that I'm going to get a very good condition for the bargaining process for a while, and you also think the same. But at some point, at some fixed deadline, we know that the game is going to end. So basically, if we don't reach an agreement by that deadline, the payoffs are zero. So the payoffs are as good as some payoffs at plus infinity to me, because so basically what this deadline is doing is it's discounting very strongly these payoffs, and we should reach kind of an agreement at that deadline, even if we disagree for a while. And the second example that they have in the paper, which is novel, is that also they show that if we expect the bargaining conditions to stay the same after this deadline, so that it's not like payoffs jump to zero, but I expect to get a fixed share of the payoff. If I expect to get a fixed share of the surplus, that's going to deliver the same kind of result. And so the intuition is that in their setup, and that's one of the innovations here, agents know the present. They know how well they are capable of bargaining in the present. They know their bargaining powers today. So they do not disagree about the present. And if the environment is very persistent, the future looks very much like the present. So there is very little scope for optimism and for delays. Okay, so let me kind of give you a brief overview of the setup. So there's a part of the setup that's very standard. So totally standard bargaining. Two players, they're both risk neutral, they discount the future at some exponential rate, and there's a fixed unit of surplus to be split between these two agents. And so, as before, there's also a proposer that's recognized with some probability. And so this is the notion of bargaining power. And they look, so basically it's a continuous time model, but they look at a discretized version in which agents basically make alternating offers in this in a grid. So basically, at any point in the grid, you're going to choose randomly one of the players to make this take it or leave it offer. But what's new here? What are they actually introducing relative to the textbook bargaining part? So one is that the idea is that the bargaining power is continuous from the right. So basically that the bargaining power is a stochastic process, and it might jump sometimes, but in general says it is a continuous process. And that bargaining power is learned contemporaneously, so that's important. People know their current bargaining positions and they don't disagree about that. So they know the present. But they might, so there's no objective probability for the evolution of the stochastic process, so they might disagree about their future bargaining positions. And given that this is true, they might expect their shares of the surplus to, when added up together, to sum to more than one. So this is going to be their notion of optimism.